any more ado, I'm really excited to introduce you to our first session for today. And that is leveraging 5G and edge networks for the smart city. And if there's anybody who knows anything about smart cities, it's probably the next speakers, who arguably are responsible for perhaps what is the world's smartest city right now. Please can you welcome Jack To and Chinn, who are all the way from Singapore. Thank you very much indeed.
Good morning and good afternoon to those who are in my time zone. Thank you, Annie, for that wonderful introduction. My name is Chinn. I'm the Senior Director and I manage the group called the Smart Nation Platform Solutions. I have two portfolios in it. One is the sensor platform, the other is the Smart District platform. I have my colleague Jack, who is be helping me go through some of the presentation. So big welcome to you. Next, please. I'd like to start and share a little bit about the context and the backdrop of our smart city initiative. We call it the Smart Nation because Singapore is essentially a city state. And what we want to achieve is basically looking at our daily lives and connecting up the technology that will make a difference in the community. And once we are connected, how we can actually imagine and create a better living condition for all of us. And I'm basically summarizing what PM Lee's vision was in his speech on the Smart Nation on the 24th of November 2014. Next, please. So what constitutes a Smart Nation? Essentially, there are six components that we are looking at. One is how we use energy in a systematic way that integrates the fabric of the city into a coherent whole. And of course, when you're integrating that, devices and the sensors that we are pulling in place allow us to collect data in which we can then make sense of it. And because of this, the community is then connected. The government is building this network and framework as the investment into it. And all the systems that we are putting in a Smart Nation are secured and trusted. And because we have these in place, we encourage a culture of experimentation. And so 5G is no less important than the other technology, but certainly for Singapore context, being one of the most densest spaces in the world, 5G certainly has a unique place in helping us resolve some of the technology bottlenecks. Next slide, please. So the journey begins pretty much in 2019. So a recent approach into 5G, while 5G has been around a while, we discussed and shared with the public our trials that we've been working on prior to that. And then in 2020, we announced the telecom companies that will be providing the solution and localizing the wave deployments. And so as we move forward over this timeline, by 2022, we will have 50% of Singapore covered in 5G. And by 2025, the entire nation will be up and running. Next slide, please. The ecosystem that we are building, in many ways, we want to work with our other agency, in this particular case, the Info Media Development Authority, who are the regulators for the 5G. And so GovTech, which my agency is in, work hand in hand in developing the innovative use cases that will support the agencies, government agencies, as well as industries. We want to ensure there is sound regulation and forward-looking framework in allowing us in the use of 5G technology and building up the talent so that they can build their application and create the wonderful technology to help us achieve the goals of a smart nation. And of course, a trusted network and resilient network is one of the keystones in having that trust in using the network. Next slide, please. So as we talk about the different innovation use cases, this is a snapshot of some of the interesting use cases that we have looked at. A smart factory that you'll find on the east part of Singapore on the right of the map. And then going from right to left, you're looking at maritime use, consumer use for cloud computing. You're looking at a living lab to allow us to look at the 5G development and R&D. And we're looking at how estate using V2X and open innovation, how robots can actually use can use that connectivity in roaming the western part of Singapore on the left. Next slide, please. Now, working in partnership with IMDA, the development of the 5G ecosystem essentially is about spearheading the technology capabilities of the whole of Singapore government. And when we collaborate between governments, we also develop public sector use cases that will benefit the public. And I will run through some examples. Next slide, please. To give you a framework and understanding, perhaps on the foundation of our Smart Nation Thrust and the use of our sensor platform network that allows us to collect a lot of this data. Now, when we are collecting this data, we are essentially trying to figure out getting more from the less space that we have. It's the idea of about connected immediacy. How do we actually become more situational aware about our city and having that conversation with it? And it's all about the sustainable convenience as well. So when we take in data, we are sensing it, we're pulling from 360 environment, both from the ground, from our air and in our seascape. And then we contextualize that data, and then we can do real-time analytics. We act on the data that we have and then get the insights, and then we bridge it back into the real world. So it's about bridging this cyber-physical world. Next slide, please. And this is a snapshot of what we do and what we are collecting. So there are different types of sensors that we have throughout Singapore. Those that are static, like lampposts and buildings and smart infrastructure, and data that we collect from mobile sensor platforms, whether it's a vehicle or whether it's a robot. And of course, there are other perspectives of data that we collect from enterprise solutions and the ones that are generated through interaction with citizens. And with this data, we essentially have that circle of sense, contextualize, and act. And from there, we are able to then make the right policies and figure out what are the different areas in which we can improve our quality of life. Next slide, please. This is a little bit about the architecture, and I won't deep dive too much into it, but safe to say that when we are looking at the policy base, we are actually enacting a framework and an architecture that is both extensible, not only through APIs and services that we will bring out through the Singapore government technology stack, in which the industries can build application on top of. We're also creating the data that is based on standards that allows system of system interoperability. Next slide, please. Once we have all these information in place and so on, and we're gathering it through the backbone of the 5G network, of course, there are different other connectivities like fiber optic and so on. But 5G has a significant role to play given the dense spaces that we have. And in many ways, we are looking at two focal groups. One is urban sustainability, and the other one is that of mobility, because these two domains essentially brings out the best in 5G in an application point of view. Next slide, please. This is an example of the COVID situation. So I'll touch a little bit on the COVID. So deploying robots to be connected to 5G allow us for that connected immediacy. This is where we have built a system beyond visual line of sight, and using the infrastructure from the communication network, we are able to control the robot to actually deliver medicine from quarantine areas. And so we are looking at this to deploy a dense network in which many robots can do the contactless technology that's required for the COVID environment. Next slide, please. This is another example where we are building up autonomy and we are picking up data that is from LiDAR or RGB cameras, and we're pulling all this point cloud into our cloud environment and infrastructure. And so you require a very high speed network, and Jack, my colleague, will talk a little bit about the edge computing and then bring it back to cloud, where the entire technical connectivity allow us for more real-time or situation awareness. Next slide, please. Another one is also to showcase the idea that smart devices like a thermal camera allow us to bring back information very quickly and then processing it to determine whether they are wearing masks or they are not wearing masks or they are doing social distancing. So the AI component and edge computing allow us to do a lot of things that we were otherwise unable to do, especially with the ability of 5G to do very dense management of many devices in pulling the data to a central location and operating center. Next slide, please. I just want to, before I pass to my colleague Jack, I just want to have a nomenclature that we can all understand why 5G is going to be a critical component of the speed time use of data, especially in the sensor data. So if you're looking at things that are real time, I'm talking about sub-seconds. So those sub-second capabilities and pushing through the machine learning or AI models right to the edge allow us for preventive and actionable, for AI to do actionable correction and being able to have situational awareness of what's happening. Anything that's actually a second above is already interactive. And we are talking about 60 seconds later, you're actually at the historical site. So taking from this Gartner explanation, where 5G takes on a very interesting and very important role is when it's doing time critical decisions. I'm going to pass to Jack now, who will share a little bit on the technical side of things. Jack, over to you.
So thank you, Chinn. Good morning, everyone. Thank you for having me. So let me see. Okay, so my name is Jack To. Kindly allow me for the next few minutes to bring you about potential applications of 5G to Singapore's Smart Nation and GovTech's Smart Nation Sensor Platform and our thoughts on 5G edge computing. Are we excited about 5G? Much has been said about the technology and their impressive rollouts already globally based on NSA. But till now, the general comments are that there are still not enough use cases to justify the needs for 5G. We, however, see it differently. In fact, we are very excited about 5G. Let me explain why 5G is so appealing to us. For those in the networking space, we all know the best form of connectivity is still wired connection using either fiber or copper mediums. Why is wired connections always the best? We know the performance when it's signed on the dotted lines of the contract. We know what to expect, what are the latencies, the available bandwidth, is it always available or subjected to overbooking. I call this predictability. And this is a very important aspect that 5G can provide to all of us. We know what performance parameters we will be getting, and knowing what is available will allow us to plan for applications according to the operation requirements and the use cases. With network slicing and high QoS assigned, we can deploy critical applications out in the open space, but not constrained to in buildings nor have to worry about the cost or disruption of outdoor wiring works. The scalability of 5G is another feature to be excited about. With the high bandwidth and high density that 5G is able to support, we will be able to interconnect up public infrastructure assets, and we can deploy much more sensors, generate more data, and create more insights. With so much bandwidth available, we can also potentially transfer the methods we deliver content and services to the public using new mediums of presentation such as AR, VR, or mixed reality. 5G has another capability that we very much look forward to. With virtualization and software-defined networking enabled in very much of the 5G networking elements, applications can now interface with the network in a more effective manner. For example, applications and 5G network can interface via API, and we can change our network parameters on a real-time basis. No man in the middle, no submitting change requests and waiting for days for things to happen. Reconfiguration can happen immediately. This to me is a game changer. Application network integration is a powerful concept, especially when you come to the near future when you basically can have AI applications running on the edge, and they can change the network services and parameters on a real-time basis. Another important feature is the support of edge computing, as we can place it in different parts of the network for different use cases. I will cover more of this aspect later. We believe 5G can bring about the next generation of digital twins, and this is a very important tool for the government. Digital twin basically replicates the physical environment and displays the information in the virtual geographical representation. We can then use this information to perform predictive analysis or run simulation. This is especially useful for city planning. 5G, however, will bring about a different level of capability to digital twins. With the high bandwidth and capability and capacity, we can connect all the sensors, including things and video camera feeds onto the platform. Alternatively, we can use edge compute infrastructure to process and analyze data on a mobile edge server and only send cleansed or processed data back to the virtual replica. 5G's URRC can transform a digital twin into a command, control, and intelligent management system. We can perform actuations and send command on real-time basis to the assets in the field. No more just running simulation on a digital twin, we can now run some management of services remotely, and simple as turning on lights on the lamp post to managing robotic swarms operation and services. Access to the system can also be extended from the users for the other users from other locations via AR, VR experiences and enhance real-time collaboration between different parts of the government. Okay, this video is a demo of a next generation digital twin and C2I platform which we are developing. The platform will virtually represent real-time information on the district on a digital twin and allow us to run smart services from this platform as well. This video shows an indoor delivery robot running some delivery errands inside an office. We can see that the robot services is triggered by a user on the platform, and there is real-time synchronization of the location and status of the service back to the platform where user can visualize. So now the robot is moving towards its first delivery. And you can see the user is tuning the angle of visualization on the platform itself to reflect to get a better view of what the robot is doing or the path is moving towards to. It has arrived at the first destination and complete its first mission, and it will move on to the second task. In the interest of time, I will not play the whole video. I shall move on. For the business aspect, we strongly believe in public-private partnerships, where the government works together with the private sector to create new innovations, build more capabilities, bringing about improvement to citizen lives and enhancing the vibrancy of the business environment. 5G can bring a very different dynamics in this space. In a hyper-connected world, the government will be able to collect a lot of sensor and public infrastructure data for its analysis and city planning. When we share this data to the businesses on a real-time basis, I believe they will find it extremely useful and will be able to create new business models and generate new revenue streams. We can also collaborate with the commercial sector to deliver enhanced public services. Of course, in this aspect, there will be security concerns. We wouldn't want unauthorized users to access our main central database, okay? And we wouldn't want to share raw data and only would want to share processed data. I think careful calibration and the use of 5G servers may be able to mitigate some of these concerns. We can have the data processed at the edge so that businesses can access the information on a real-time basis and can have users access the edge for live data via authorized network slices, which we can create out of the 5G network, allow us to better manage the cybersecurity compliances. Next is the citizen aspects. Digitization is a key pillar of Singapore government public service transformation efforts. We have digitized a lot of government services for the past few years, and GovTech has also launched a number of apps for citizens and businesses. A lot of our services and information can now be consumed on mobile devices. We are, however, cautious what are the type of end devices that are used to access our applications. We don't have to worry too much about the devices now, the OS, as there are mainly only two types now, Apple and Android, but the different versions are sometimes still a concern. We also have to take note of the minimum specification of devices and the security mechanism that are available in the device. While 5G may not totally solve this problem, but I think there are room to improve on this aspect using 5G. With the high performance capability of 5G, the high network and low latency, we can basically process everything backend and use the device simply as a presentation layer device only. To ensure performance and positive experience, we can push all this information and application out to various parts of the 5G network using edge compute, and to be closer to the citizens where they access the data. 5G is a game changer. It changes the way we can deploy our applications, enable new types of applications that can be supported, and hence allowing us to deliver new services and capabilities. In the diagram shows the possible breakout points for MEC of a 5G network to cater for the applications of different requirements for latency, security, and routing between devices. For example, we will want applications that run AI for critical applications or autonomous robotic platforms to be hosted on-prem or at the telco edge to be as near to the device as possible. For simple transactional service or info query, the application can be hosted in the public cloud. How about hybrid solutions, where we host critical real-time functions of an application at the edge, and we still use the cloud mainly for storage and reporting functions? Therefore, 5G, because of its capability and dynamics to support different application types, will drive a lot of changes in the industry, including changes in application architecture as to achieve the optimum performance against cost. The more we deploy on the campus or at the telco edge to be nearer to the devices, the number of service instances we need to create will increase and hence driving up the cost. As part of our Smart Nation initiatives and development, we will be requiring to host our applications in different parts of the 5G network for different application types. We need to achieve a balance of cost, efficiency, and effectiveness for our deployments, which I foresee will be a very difficult equivalent to achieve. Everyone wants the best performance, but everyone wants the lowest cost. So we have to see how it goes for this aspect. Now that 5G can help to offload application processing to the edge servers, how will it change the ecosystem of devices? Will it become smarter or simpler? With possible offloading of application processing to the backend system enabled by the low latency and high bandwidth of 5G, will handphone devices start to become only display devices? Well, we don't have an answer. It will be interesting to see how this develops. But for us, Smart Nation Sensor Platform, where we deal with sensors and robotics, we actually do look forward to sensor devices and robotic hardware becoming simpler. Simpler hardware will result in the device become lighter and consume less power. With this, our drones can fly further, our robots can carry more payload and operate longer before a recharge, and sensors can be deployed more pervasively without overstressing the power grid. We have discussed a few points about the benefits and possibility with MEC and edge compute. However, we are mostly still waiting for telcos to implement a full SA network that can deploy the full capabilities of 5G. I think the near-term focus is probably for rollout of base stations to achieve coverage, and edge compute within 5G may take a little bit longer to mature, and standards may take longer to evolve. Singapore-wise, I think we are probably in a slightly more unique situation. Our total land area is just over 700 square kilometers, and the latency from one end of the island to the other is probably still acceptable to most applications. In this context, do we still need edge server? How much of it will we need? We don't have an answer yet. It will be interesting to see how things evolve, but my gut feel is we will need some form of edge compute, but probably not to the scale compared to the other countries like yours. There are a lot of other factors that hopefully can be more standardized, as standardization can help to hasten the development of the ecosystems. For example, what are the technical standards for MEC? Where can the edge compute servers be deployed? Can it be at the telco base stations, or can we even have end devices as MEC? I think the possibilities are limited, and we probably need more time to see this mature in the next few years. I personally have a perfect desired combination of 5G. Okay. For smart city applications, a combination of network slicing, URLC, and MEC is paramount for us to be able to develop and introduce new generation of services for our citizens and businesses. This combination will provide us with three key benefits. Network slicing and class of service provide us the assurance of available network resources. URLC give us assurance of network parameters, performance parameters that will allow us to plan our application architecture and deployment models. MEC will enable our applications to be nearer to the devices for lowest latency communications, which is vital for critical applications which has real-time requirements and autonomy, especially when it comes to interconnected robotic applications. So yeah, we are really looking forward to 5G and developing new applications on top of it. With this, I have finished my part of the presentation and will pass back to Chinn. Thank you everyone for your time. Chinn, please.
Thank you, Jack. I think what's exciting is that there are many opportunities we can look to experiment this way. We don't have the monopoly for the solution, certainly for a smart city, but by sharing ideas and learning from everyone, I think we can certainly at least put it out there. We are a city willing to try, willing to experiment, and we have the will to basically look at what is important for the community and allow our technology to make that difference, and connecting both the people with the technology and creating a space that is both sustainable in terms of the way we use technology and creating a better quality of life. With that, I want to thank everyone for listening in, and happy to continue answering the questions that you may have. Back to you, Annie.
Thank you very much, Chinn and Jack. So we've had quite a few questions. One is asking, do you think a higher penetration rate, a technology penetration rate, is necessary for successful 5G rollout?
It certainly helps. As you know, the 5G rollout actually can be done in batches, right? You don't have to actually make sure that the entire country is all 5G before you switch it on. What is useful in our discussion, where the return on investment, I sort of answered it a little bit, is that we have to look at where areas have a lot of footfall. And we look at areas that are actually industrial in nature, because in the industry where, especially the manufacturing industrial areas, they're looking at configurable factories. And so with configurable factories and with very high density IoT that's required, and they want to change the setup, so 5G can certainly play a different role there than, say, out in an area where there are more parks. So the mixed residential, the way the urban areas are designed and where they're zoned makes that difference. And so if you are looking at a place, for example, upmarket street, where you want to have the best experience and you want to push the experience of a shopper, and then you want to have advertising and everything that's going on in the context of where there are at least 10,000 person per square kilometers, that actually ups the scale, and then that will give you an idea how to calculate for the return on investment.
That's a lot of people in a small space, isn't it?
That's right.
To handle with. Regarding GovTech, where do you know, how far have you got in figuring out where the line is between performance and cost? And do you think there will be different classes of service at the edge? Maybe a service level agreement around parameters for different applications?
That's a good question. So from the context of Singapore, a lot of the initiatives are driven in two ways. One, certainly with the license that has been given out for the telcos. We respect the fact that the market forces will drive a lot of those needs. And we will leave to the interaction between the enterprise and the telco, and the telcos will then react in a way that best meet those needs from a market force point of view. From a government point of view, we're actually looking at the economic considerations. We are looking at the innovation that needs to come of it. What is the force multiplier, if you will, that allow the entire nation to be able to work in an environment that it's a lot faster, right? That the connectivity is a lot smoother, the user experience is a lot better. So that means in business engagement, there is a certain quality of service in terms of a citizen, whether they are playing game or just enjoying a Netflix there is, while they're moving about, is also another level. So what ultimately must happen, like all technologies, is that there must be a quantifiable benefit. It's one thing to say we think it's fast, we think it's useful, but then how much faster, how much useful does that translate economically? Given the COVID situation where everybody sort of works from home, and then you actually have a dynamics that's coming, because the whole idea now that you don't actually have to be in the office to get work done, it may mean that you may have a global workforce. So if you actually had a country that is well connected and a country that is not just well connected within the country, but connected to the world, you have that edge. And so that edge is what we are looking for. And our hope is obviously with the innovation that can come from it, and the speed that we can enjoy, and then the ability to splice some of these things and slice it, we will be able to enjoy the benefits from the cost savings in the economies of scale.
Okay, so there's going to be different classes and different types of service for different applications. That's, I guess, is one of 5G's big attributes, that with network slicing, you can do lots of different quality of service and classes of service.
That's right.
Is that a key? And I imagine that might be key to the economics too.
Yes, absolutely. Yeah. Because one of the key things is that we are even looking for 5G for the government agencies use. So well, we can split one that's for public use, and we can split one that is actually for government use only. So certain data that moves around, the way we handle it would be significant. I want to also bring Jack in to make a comment on this. Jack?
Please do.
Yeah.
Hi. So the what is the line between performance and cost? Sorry, am I mute or okay?
Yeah,
So
no,
I think when we look at performance and cost, there will always be benchmarks, and that's how we justify all our investment in all our operation and services. And I would think that there will be various benchmarks for us to look at. In one of the slides, I talk about the best form of connectivity is still wire connectivity. So when we look at 5G and performance, we probably will be looking at doing some benchmarking against the current fixed line of wire access. And people will ask, if your 5G is so much more expensive than fixed wire access, is it even worth it in the first place? So these are the questions that we need to answer. We don't have the pricing scheme from the telcos yet regarding 5G because it's so new, and because SA has not been fully implemented yet. So we really have to answer this question along the way. So would there be class of service for the edge? I would rather say I think we must have class of service for the edge. The edge, unless we talk about the situation where we, the government, deploy our own edge in the telco cloud, which is a possibility, like what Chinn is mentioning. We are potentially exploring having dedicated slices for the government use. And when we do that, we will probably have our own edge. On the other hand, for economics of scale, we may want to leverage on the telco edge. And when we leverage on telco edge, definitely there will be some expectations on preferential access, especially when it comes to critical applications. When we run critical applications, we want to ensure we are able to see, able to visualize, and able to act. Okay, to react to any situations that is out in the streets. So this gives us the assurance that we can provide to our citizens that we are in a way managing the situation, having the situation on hand. Yeah. So I hope that answers the question.
Thank you, Jack. And also, just one more, and then sadly we've got to finish. But so, in case anybody's not following the Q&A channel, Andreas asked Chinn if he have supported features to manage data ownership and to forget data. And Chinn answered that we have a national policy on how data is handled, protecting privacy, and to ensure secure storage when it's needed. So for example, AI and machine learning models for edge compute that pick up metadata via 5G to the IoT data lake for further processing. So then Andreas asked, I'm sorry, this has moved around a bit. He asked basically about, can you support that approach to data? Is there any policy, or is it tailored to what you have today? So can you apply different policies to different data models, I think, and different sets of data?
Today is tailored. So we are at a very nascent state as we are working in 5G. So it is very much tailored. We haven't got one that is essentially broad-based because we haven't have enough use cases to figure out what makes sense. So we are tailoring the needs at this moment.
Okay, so it's very early days. That was a really terrific and interesting session. Thank you very much, Chinn and Jack. Thank you very much indeed.
Thank you.
Pleasure. Thank you very much.